Let's dive right into this explainer and completely unpack the architecture of Proxmox VE. Because look, whether you're just tinkering with a home lab out in your garage or you're managing massive enterprise infrastructure across dozens of racks, truly understanding how Proxmox structures its environment, that is the absolute secret to mastering its web interface. So today, we're going to connect the underlying theory directly to the buttons you're clicking every single day. We're going to turn those complex admin tasks into logical, predictable workflows. Sound good? Let's get into it. Here's how we're going to break it down today. First, we'll look at the big picture hierarchy. Then, we'll clarify hosts, guests, and nodes. After that, we'll hit storage and networking basics before moving on to navigating the actual web interface. And finally, we'll wrap up with some real-world troubleshooting. All right, part 1. The big picture hierarchy. The Matryoshka dolls of Proxmox. Seriously, thinking of Proxmox like a set of Russian nesting dolls is literally the best way to visualize it. You really have to view the environment from the top down. So we start at the absolute highest logical level, right? The data center. This is your administrative umbrella. It holds all the global settings that apply to your entire environment. Things like user permissions, overarching firewall rules, backup schedules for the whole shebang. Now open that top doll and you find the clusters. Inside a cluster, we step down to the actual bare metal, the physical nodes. And finally, you pop open a node and there they are, the individual guests. These are the virtual workloads, the databases, the web servers that are actually running the business. Grasping this top-down flow is absolutely crucial because settings cascade downwards. Let's look a little closer at that second layer. A cluster is basically just a group of Proxmox nodes managed as a single, cohesive environment. So instead of logging into, say, 3 or 10 separate servers one by one, you just manage one unified platform. This right here is what gives us high availability. If a physical node suddenly loses power or the hardware fails, your virtual machines can automatically restart elsewhere on a healthy node in that cluster. Pretty cool, right? It also enables live migration. Think about it. Say you need to do emergency hardware maintenance at 2 p.m. on a Tuesday. Live migration lets you move running workloads between physical nodes with zero downtime. You literally prevent any service disruption while you swap out a bad RAM stick. Moving on to part 2. Hosts, guests, and nodes. Finding the problem layer. Okay, separating the physical stuff from the virtual stuff is a golden rule that will save you hours of headaches. The host system is the actual physical server running Debian Linux and Proxmox VE. It provides the physical CPU, the RAM, and the storage. The guest system, on the other hand, is the virtualized workload. Maybe it's a Windows server or a custom database, and it's just consuming those allocated resources. So when you're troubleshooting, figuring out which layer you're dealing with is literally half the battle. You always need to take a step back and ask yourself, wait, is this a host problem like a dead network card, or is it a guest problem like a crashed application service? Now, inside the host, you'll run into 2 specific types of virtualized workloads, and they operate very differently. First up, virtual machines. These use KVM virtualization to run fully independent, heavy-duty operating systems. It's basically tricking a full Windows server install into thinking it has its own dedicated hardware. It's totally isolated, but yeah, it does have some overhead. Then we have containers, which use LXC technology. Containers are incredibly lightweight because they actually share the host's Linux kernel. Since they don't have to boot an entire OS from scratch, they can be up and running in mere seconds, using just a fraction of the RAM. Knowing if you have a VM or a container completely changes how you'll allocate resources and handle backups. Let's jump into part 3, storage and networking basics, the lifelines of virtualization. Let's be real, without storage, virtualization just doesn't happen. Proxmox supports a few core types right out of the box. First, you've got traditional directory storage, which is your standard file system setup. Then there's LVM, giving you flexible block-level allocation. After that is ZFS. This is a super advanced, software-defined file system packing brilliant enterprise features like built-in data integrity checks, instant snapshots, and asynchronous replication. And finally, shared storage. Things like NFS, ISCI, or Ceph. This is the magic that makes those high-availability clusters we talked about earlier possible, because multiple nodes can access the same virtual machine disks at the exact same time. From a support side, keep a close eye on your storage capacity. Full storage pools are a massive and honestly often overlooked reason for VMs just suddenly freezing or crashing entirely. On the networking side, everything hinges on the Linux bridge, which you'll usually see labeled as VMBR0 in Proxmox. Think of it like an invisible, virtual network switch living right inside your physical server. Your physical server has an actual network cable plugged into a switch on the wall, right? Well, the Linux bridge takes that single physical connection and lets dozens of virtual machines plug into it virtually. If that bridge isn't configured right, your virtual machines are completely stuck in a digital darkroom. No internet, no talking to each other, and your users definitely can't reach them. All right, on to part 4, navigating the web interface, driving the machine. So one of the biggest strengths of Proxmox is its incredibly robust centralized web interface. But to get in, you need to know the magic number, port 8006. By typing HTTPS, followed by your server's IP address, and then :8006 into your browser, you get secure, encrypted access to the admin control panel. It seems like a minor detail, but it's super important. If a user is panicking because they can't log in to manage your infrastructure, verifying that port 8006 isn't blocked by a local firewall is always step 1. Once you're inside, the level of control you have is just incredible. From that one single browser window, you can deploy brand new containers in seconds, configure complex ZFS storage pools, set up automated midnight backups, and monitor live metrics like CPU and disk I/O. Now, Proxmox is built on Debian, so sure, you can drop into the command line via SSH if you really want to. But the beauty here is that almost all your day-to-day administration can be handled effortlessly without ever opening a terminal. It really democratizes advanced virtualization management. The interface itself is logically split up into 3 primary areas, mostly to keep you from getting overwhelmed with information. Over on the left side, you've got the navigation tree. This is exactly where those Russian nesting dolls we talked about are visually represented, cascading from the data center at the top, down to the nodes, and then the guests. Right in the center is the main workspace. This area is highly dynamic. Whatever object you click on the left instantly populates this center screen with its specific resource usage, hardware configs, and historical metrics. And finally, down at the very bottom, there's the taskbar. That keeps you constantly in the loop on system alerts, running background jobs, and error notifications. Bringing us to our final section, Part 5, Real-World Troubleshooting, Connecting Theory to Practice. Okay, here is the classic scenario that makes every sysadmin's heart skip a beat. A support ticket pops up, and it just says, "My virtual machine is completely down. What do I do?" So how do we actually translate all that architectural theory we just went through into rapid, effective troubleshooting in the GUI? When everything seems broken, where do you even start clicking? Well, there is a very logical flow to this. First step, check the data center and the node. Is the physical host actually online? Remember the hierarchy we talked about. If the physical node is dead, every single VM on it is dead too. If the host is fine, then you select the specific virtual machine in the navigation tree and look straight at the Summary tab. This tab is your absolute best friend during an incident. It gives you an immediate, high-level overview. Is the VM CPU pinned at 100%? Is the memory completely maxed out? Next, verify your storage health, because again, a full storage pool will freeze a VM in its tracks. And finally, check those networking configurations to make sure that vital Linux bridge hasn't been somehow disconnected or misconfigured. Now, what if an administrative action failed? Say a user tried to start a VM and it just straight up refused to boot. You want to immediately pivot your eyes down to the task history logs at the bottom of the interface. Every single action taken in Proxmox generates a log task, and you'll see statuses like OK, warning, or error. Spotting that error status is incredibly valuable. If you double-click that error task, it frequently reveals the exact root cause directly in the system logs. That alone will save you hours of blind guesswork and get your systems back online so much faster. But what if the VM is actually running, but you just cannot reach it over the network? Maybe SSH is rejecting connections or remote desktop keeps timing out. This is where the web interface's console access becomes your ultimate safety net. By selecting the VM and clicking Console, you get direct interaction with the workload. It behaves exactly as if you walked into a freezing, noisy server room and plugged a physical monitor and keyboard directly into the back of the server. Because it completely bypasses the guest's broken network configuration, the console is the absolute definitive tool for direct operating system recovery. So understanding this architecture is truly what unlocks the power of the web interface. Knowing how the data center manages the cluster, how the node hosts the resources, and how the guests consume them, that tells you exactly where to look when things go sideways. The next time you're facing a critical outage, before you just start clicking around aimlessly, stop and ask yourself, which exact layer of the virtual Matryoshka doll am I truly in? Because once you master these layers, you have to wonder, What other complexities in your infrastructure could you simplify?